The planet Pluto is at the edge of our solar system, surrounded by a huge group of cold, heavenly bodies and space rocks in the Kuiper Belt, which is a huge area of space beyond Neptune. Pluto was once thought to be the 10th planet. Its name comes from the Roman god of the hidden world. However, Pluto was demoted from a planet in 2006, which marked a turning point in the history of astronomy and showed how our knowledge of the space around us has grown. There are a lot of interesting things in the planetary system right now. There are a lot of big celestial bodies, a lot of space rocks, a small group of minor planets, and only 8 known planets in human history. Our understanding of these bodies, including their makeup, behavior, and possible traits, has grown a lot thanks to this study of the universe. It gives us a fuller picture of our place in the universe. Even though we know more now than ever before, the beauty of life still makes us want to explore and find new things. The James Webb Space Telescope, which is the latest and greatest in astronomy, is ready to reveal some of these long-awaited insights, including those about Pluto. Pluto has had a special place in the hearts of many for years, even though it is small and has an odd orbit. It is happy to be the smallest celestial object in our nearby planetary system. People had strong reactions to Pluto's new name, which showed how connected they felt to this faraway body. Still, scientists were careful to say that an object could only be a planet if it met 3 main conditions. It had to orbit the sun, have enough mass to take on a nearly round shape under the sun's gravity, and keep its orbit free of debris. Pluto failed to meet all 3 of these conditions because its orbit was not a smooth circle. In the history of astronomy, the word planet has changed in fascinating ways. At first, it meant any large celestial body seen in the sky, such as moons and comets. When American astronomer Clyde Tombaugh found Pluto in 1930, it caused a lot of joy around the world. However, other objects of the same size were later found in the area, which made people wonder if Pluto really was a planet. During this debate, Professor Mike Brown made the important finding of Eris, an object in the Kuiper Belt that is almost the same size as Pluto. This made things even more complicated and called into question the traditional definition of a planet. Astronomers had a lot to say about this, and in the end, Pluto was reclassified as a dwarf planet at the 2006 meeting of the International Astronomical Union, IU, in Prague. So, Pluto's change from a planet to a dwarf planet shows how scientific knowledge is always changing and how we are always trying to get a better picture of the world. A new definition of a planet was put forward and voted on at the IU meeting in August, after a lot of debate. This new meaning of a planet included both Pluto and Eris, which was different from the usual idea of what a planet is and showed a more complex view of celestial bodies. Eris, which used to be called 2003 UB313 and was also known by the name Xena, was named after the Greek goddess of conflict, which is a nod to the arguments about how to classify it. Planetary scientist Mike Brown at Caltech did work that helped Pluto be reclassified. For his efforts, he got a lot of attention and was called the Pluto Killer on social media. As a result of this change, educational materials, such as textbooks, were briefly updated to represent the new idea that Pluto and Eris are dwarf planets. But not everyone in the scientific world agreed with the IU's definition. Concerns were raised by some planetary scientists, especially those who study Pluto and other similar objects. This started ongoing talks in the field of planetary science. People outside of science were talking about these issues, which made people wonder about the possibility of exact classification and the effects of changing the names of long-used astronomical terms. Even with these arguments, science research kept going. NASA's New Horizons spacecraft made a famous flyby of Pluto in 2015, giving us a lot of new information about this very faraway world. The mission showed a planetoid that was changing shape and moving, with features like nitrogen ice fields and a large heart-shaped area that caught people's attention. It's clear that our knowledge of the nearby planetary system and its bodies is still changing as we think about these new events. Pluto and Eris have been reclassified as dwarf planets. This is a big step forward in our study of the universe and shows how complicated and varied the worlds beyond Earth are. At an amazing 32,300 miles per hour, New Horizons was traveling through space, and it took clear pictures of Pluto's near side when it got the closest. But because of the spacecraft's path and the sun's position, they couldn't see Pluto's far side, which is sometimes called the dark side. To learn more about this mysterious area, researchers carefully looked at pictures taken by the spaceship before it met the object. Even though the pictures were limited in scope, they showed a level of detail that had never been seen before, letting scientists see features on the surface that were as little as 1 mile across. This detail was much better than what had been seen before, even by the Hubble Space Telescope, which orbits Earth. The study of these pictures has given scientists new ideas about how Pluto changes over time. For example, they are looking into the possibility of a deep ocean and surface cycles. New findings, like the fact that Pluto's surface has ammonia and strange ice formations, keep showing how complicated this world is. Richard Binzel, a planetary scientist who is part of the New Horizons project, says that Pluto is the gift that keeps on giving because it keeps surprising scientists with new discoveries. Before the New Horizons journey, the Hubble Space Telescope took the clearest pictures of Pluto. These pictures showed a world with clear surface features. But New Horizons gave us important up-close views of Pluto's scenery, such as the beautiful heart-shaped area and the huge frozen plain called Sputnik Planitia. The discovery of Sputnik Planitia's unusual arrangement next to Charon, Pluto's largest moon, has sparked interest in how it formed. Some experts think it may have a subsurface ocean that has changed the features on its surface. The fact that ammonia is found in the ice covering Sputnik Planitia says that there is geological activity below the surface, which shows that the world is changing and growing. As scientists continue to look into the data that New Horizons sent back, they are learning more about how complex and changing Pluto is. This opens up new areas to study in the future. The varied terrain on Pluto's far side, with its hills, valleys, and plains, looks a lot like other celestial bodies that have oceans below their surfaces. Scientists are looking forward to future trips that will allow them to get a better look at Pluto's far side. Strange things seen add to theories about Pluto's geological past and how its ocean below the surface shapes its surface. As New Horizons continued its journey, scientists thought about what might happen to Pluto's core in the long run. Radioactive breakdown in the core might have created enough heat to change the shape of the surface, possibly causing cracks or wrinkles like those on Earth. But when New Horizons took pictures of Pluto's far side, it saw holes instead of the usual wrinkles. Pluto's surface looked like it had partly frozen over time, and this large crack running along its near side looks a lot like Earth's East African Rift system. It's likely caused by a subsurface ocean freezing and expanding. Based on how old this fracture is, it looks like the ocean started to cool down quickly after it reached the top, which may have made conditions good for life to start growing. The reddish color of Pluto's surface, which is a sign of organic particles, also points to the presence of complex organic molecules. Tests in the lab have shown that these particles can be made by radiation like cosmic rays or solar wind. This suggests that they might be on Pluto. Ammonia-bound ice was found on Pluto's near side, which supports the idea that the dwarf planet may have a lot of organic molecules. This doesn't mean there is life there, but it does mean that conditions could be good for life if they were right. Measurements taken from Pluto's far side have not only proven that the journey was successful, but they have also shown us some interesting landforms, such as ice formations that look like tall buildings. These changes, which are spread out and getting more attention, pose a major mystery. Spectral readings show that they are made up of methane ice and form a belt around the equator. However, no one knows where they came from. Theories range from condensation in the atmosphere to breakdown by intense sunlight. To fully understand Pluto's cold climate and scenery, we must first carefully examine its atmosphere. Climate models are being improved so that they better reflect the patterns that have been seen. Scientists also want to make the atmosphere and surface of Pluto behave like they do on Pluto in the lab. The James Webb Space Telescope can't take high-resolution pictures of Pluto, but its longer bands might give us more information. As we continue to learn more about Pluto, we are starting a journey that shows how people are always wanting to learn more and how our understanding of the world has changed over time. The James Webb Space Telescope's ability to gather and examine infrared light makes it possible to study objects between stars, including those that are passing through our solar system. With its advanced features, the telescope lets scientists look deeper into the secrets of these faraway visitors, giving them a better idea of what they are made of and where they came from. This ongoing study shows how important it is for scientists to keep looking into the mysteries of our very large and interesting universe. The James Webb Space Telescope is the start of a new age in cosmology. It uses cutting-edge technology to study faraway objects in space and visitors from other stars. Due to its advanced infrared powers, the JWST can see huge events that are normally invisible to regular optical telescopes. This lets scientists study the early universe, star formation, and the makeup of exoplanets in great detail. The JWST's ability to pick up infrared light is one of its most impressive features. This is needed to find things that are too dim or too far away to be seen with visible light. The telescope's huge main mirror and high-tech tools let it pick up the faint thermal signatures of galaxies and other cosmic objects that are far away. This ability is especially useful for understanding how galaxies form and change over time, as well as the atmospheres of other worlds. It's clear that the JWST has helped us learn more about the universe by showing us intricate information about objects in space. For example, its studies have given us new information about the makeup and structure of galaxies far away, which has helped us understand how they have grown and changed over the course of cosmic time. By looking at the atmospheres of exoplanets through the telescope, we now know more about how habitable they might be and whether they have things like water vapor and methane in their atmospheres. Exploring things between stars reveals hidden facts about the universe. Interstellar objects like Oumuamua, a strange visitor from outside our solar system that got a lot of attention when it was first found in 2017, are one of the most exciting things about the JWST project. Unlike any other object seen before, Oumuamua had an unusually long form and moved quickly, which led to a lot of research and speculation about where it came from. The JWST should be able to give us more information about these cosmic objects by looking at their structure and paths. Scientists want to find out more about where they came from and how they were thrown out of their home star systems. This information can tell us a lot about how other solar systems formed and changed over time. Pluto is still a very interesting place for scientists to study because it is part of the Kuiper Belt. A lot of knowledge about Pluto's surface and land features was found in the data from the New Horizons mission. As scientists look into these new findings, they hope to learn more about the processes that change bodies so far away. The JWST studies could add to and improve what New Horizons found by giving us more information about how Pluto and other Kuiper Belt objects are made and how they move. Learning about these faraway worlds is important for figuring out the past and development of our solar system and other planetary systems in the universe. As the JWST continues its goal, it is likely to make important discoveries that will help us learn more about the universe. Now that the telescope can see in the infrared range, we can look into parts of space that were harder to see before. For example, we can study the atmospheres of exoplanets and visitors from other stars. The JWST is about to make important advances to the study of the universe. We will learn more about solar systems other than our own as we continue to study Pluto and other objects in space. Researchers can get a fuller picture of the world and all its wonders by putting together data from different missions and telescopes. In conclusion, the James Webb Space Telescope is the most advanced piece of astronomical equipment ever made. It gives us amazing new information about the world. Its cutting-edge technology and abilities promise to reveal new secrets and help us learn more about the universe. This will pave the way for more finds and increase the amount of information people have.